Hi, welcome back to AP Physics 1, Unit 4, Work, Energy, and Power. This is the last video for this unit, right? So you've made it all the way through Unit 4 WEP. And remember, this unit is very important. This is one of the big portions of the test. So here with power, right, this is a word that gets thrown around a lot. And the way we like to talk about power is just really the measure of how quickly work is done, right? So if you look here, it says more accurately, it's the amount of work done in a given amount of time, right? So that's kind of like the official definition. So it's like how quick we get the work done. So you'll see a lot of relationship questions here, like which generates more power, this situation versus that situation, right? Or rank them, okay? And so to the powers, to get power, we simply do work over time, right? Or change in work. In fact, it's rarely ever a change in work. You would get work over time, okay? But that work, you got to remember, is also equal to change in kinetic energy over time, right? So you can kind of go down this whole like relationship, and then ultimately you can find that it's the change in energy over time, the change in potential energy over time, okay? But here in AP Physics 1, we're just kind of generally in this area, okay? The SI unit for power is watt. It's named after James Watt, in the perfecter of the steam engine, right? So, but what happens is the unit is so small that you will use kilowatts as a unit. So a light bulb is what we call electrical power, right? So a 60-watt light bulb generates 60 joules per second worth of energy or electrical energy, okay? Here's, right, this picture, this is the famous power reader, right? So people, when you get charged for your electricity bill, this is the device that they will come around to read. Now they're digital, right? So they may not have to necessarily come out and read it. I remember growing up, we visited my grandfather in Denmark. This device was inside the house. So my sister and I were able to like turn everything on and the disc would spin, right? But you can see right here, it says kilowatt hours, okay? Then you get charged per kilowatt hour, like 5 cents per kilowatt hour. It's very cheap, but it's more like 13 cents per kilowatt hour, okay? Now, here in the United States, a more common unit for power is horsepower. Why is it common here in the United States? Because of cars, right? My engine has so many horsepowers, right? And well, what happened was Watt had to kind of like define to people, what his machine can do. He says, oh, my machine can replace that many horses, so it's that much horsepower, okay? And I think what he said was like his unit was equivalent to like 3 horses or 4 horses or something like that, okay? But sometimes what you'll see is if you have a pool, these are also how pool motors are rated, elevator motors as well, right? So there's a lot of usage of this. And 1 horsepower is 746 watts or 0.746 kilowatts, right? Because you may have to do a conversion. Not very common on the AP test, but you may have to do that conversion at some point in time. All right, so let's look at an example. So here we have a driver passing a minivan. So they have a 1,300 kilogram car. They're going to go from 13.4 meters per second to 17.9 meters per second in 3 seconds. And we're just trying to figure out what is the minimum power required to do this, okay? So we know power is work over time, right? But we need to figure out what work is. But remember, we have that relationship, the work-energy theorem. Work-energy theorem says that the work done is equal to the change in kinetic energy. Right? So find the amount of work that the car did. We just simply do 1/2 mass times v squared minus VO squared. So 1/2 times 1,300 times 17.9 squared minus 13.4 squared. Okay? So how much work did they do? I have it somewhere, 9.2 times 10 to the 4th joules. So in going from 13.4 to 17.9, they did 9.2 times 10 to the 4th joules of work. So that becomes our W, right? And we do that in 3 seconds. I did want to point out, I forgot to do it when we were just doing the information slide. So power is directly proportional to work. So the more work done, the more power. The more common question will come in related to time. So the more power, to generate more power, I decrease the amount of time. So once I decrease time, because they're an inverse relationship, that power will go up. Right here, if I increase power, right, or if work goes up, power goes up. Okay, so how much power did we do in the 3 seconds? Well, we did 3.1 times 10 to the 4th watts. Now, you may be asked to convert this. So this is 31 kilowatts. All we do is simply divide that number by 1,000, or it's 40.9 horsepower, right? To get to that, we do 3.1 times 10 to the 4th watts. We know that 1 HP is 746 watts, and we get an answer of 40.9 horsepower. Okay, so this video concludes Unit 4. Again, this is a very important unit. This is one of those units that has a good portion of the multiple choice questions. So make sure you really do understand this unit. And typically, there's one question in the free response that centers around this energy unit. Can't wait to look forward to moving on to Unit 5, which will be